Alright, now in this video we're gonna go over writing the interrupt functions for our GPIO to generate interrupt on specific pins. Now before we go into actually writing the functions, I want to get an overview of how it is that the interrupts work on the ARM Cortex processors. So to do that, I'm going to give a brief explanation of how it is that it works. Basically, in the processor, what you have going on is the way it handles interrupts. I'm going to draw this out because it'll be much better to understand. What you have going on is basically this. You have your let's say this right here is your M3 Cortex, right? This is your core. Inside of it, so to speak, NVIC, you have the NVIC, and this handles basically all the exceptions that can come from the core itself or from different peripherals such as the GPIO and things like that, and other peripherals like the I2C or the UARTs, etc. And I believe the first 15 interrupts, let's say these are all interrupt lines, correct? The first 15 lines are internal, right? It has to do with the core, with reset and other things like that. And then the lines that remain come out here, right? It's not exactly that many, but let's just say it is. And some of them are out here. This right here, this block is called the EXTI, the external interrupt block. On this block is where your GPIO interrupts are connected. So what ends up happening is that when you enable an interrupt for a GPIO, you're gonna enable it here, right? So let's say this interrupt line right here corresponds to, let's say, I don't know, GPIO on port B, pin 4, right? And then this line right here, as you can see, is line 1. But over here, it's not line 1. Over here, let's say it's line 16. So you're gonna have to enable line 16 on the NVIC, line 1 on the EXTI block to enable GPIO port B pin 4 external interrupt, as well as do a couple more settings on this external block. Now this number, to get this number, to find out what this number is, that's the IRQN, the IRQ number, and I'll show you how to find this, and we'll also figure out how to find this number and all of that good stuff. I mean, so that's a very, very basic idea of how it works. So let's see what it is that you actually have to do to get all of that working. So let's first look at the NVIC. The NVIC is the one that's internal to the processor. And if you go on section 10.1 on your data sheet and you go to the 10.1.2, you'll see this table. This table shows most of the interrupts that are on the that the Cortex handles. As you can see, you have interrupts for your timers, for I2C, CAN bus, direct memory access channels. These interrupts right here are the ones that go from that NVIC block, like that block that goes to the EXTI. So these lines are the ones that control your GPIO lines. Okay. Another thing to notice is that you have these settings right here. This position, priority, type of priority, description, and address. What this means is, let's look at this example. Let me make this smaller so that it's you can see the top or not. Anyways, what this is telling you is that the EXT, the external interrupt line 0, that's what the 0, the 1, and the 2 mean, is position 6. So the IRQN, the number on the NVIC, corresponds to position 6. So that's the IRQ number on the NVIC. On the EXTI block, it's line 0, as you can see right there. And this is telling me that it's the priority is settable, so you can actually change the priority. So for example, if you have both of these interrupts happen at the same time, this one and this one, you can change the priority of them so that you can control which one happens first. And the lower the priority number, the higher the priority. So if this were priority 2 and this is priority 4, this one would execute first should they both fire at the same time. This right here is just a description that is telling you that this is the external interrupt line 0. And this right here is the address of the handler. So obviously when an interrupt happens, it's happening because you want your program to do something. Well, this address right here is where the function should be located that is going to control, it's going to handle your interrupt basically. And you don't have to worry too much about this because it's already mapped, and I'll show you how to find that. So you just start, you just write a specific function name and it'll be mapped to this address, and then whatever you put in that function is what's going to happen when your interrupt fires. Okay, so I'm showing you all of this in the datasheet, and I'm going to show you where to find it in your actual application. Okay, so that's the NVIC table, and again, it has all the interrupts that are coming out of the NVIC or into it, however you want to see it, the position numbers, the addresses, what they do, and if their priority is settable or not. Okay, let me just go ahead and show you that in the actual application itself. If you go to this file right here, the Stm32 F1 10x.h file, and you type in IRQN, if you press Control F and you type in IRQN, it'll bring you to this, which is kind of close to the top of the file, and it has all of those interrupts with their respective position numbers. So I could just type in IRQN and it'll return the value 6, the proper position number on the NVIC line when it's time for me to activate it. And I'll show you how this is all relevant once we start coding. Now the next thing thing you need to know about is the actual registers that you're going to use, which are the of that external interrupt block. And this the description for this starts at 10.2, page 206 on your manual here, and you can read that. So I'm just gonna go over the some of the basic things. As you can see, this is telling you that external interrupt block has 19 different lines, okay, and they correspond mostly to your GPIO pins and a couple for some extra stuff. So as you know, each port has 16 pins, so then that leaves a couple of interrupt lines for other stuff. Now the way this works is like this. EXTI0, which is external interrupt line 0, which is the one we just saw on the NVIC that was position 6. Again, let's say this one right here, external interrupt 0, 1, 2, 3, and 4, etc. The way this works is like this. If you want an interrupt on port A, pin 0, you're going to use external interrupt line 0. If you want an interrupt on port A on pin 1, you're going to use external interrupt line 1. As you can see, this right here is a multiplexer. These are multiplexed into a single line. So you you can use multiple of these on the same interrupt line. For example, you can have port A 0 and pin B 0 and port B 0. The thing is, when you do that, you have to figure out which it came from, because it's not going to tell you which one set the interrupt. You have to figure it out yourself. So it's more tedious to do that. If you want more than one interrupt, it's better just to set them on separate lines. That way each of them execute their own code, as opposed to you trying to figure out, okay, which pin 0 set off this interrupt. As you can see, all the port pin 0s are mapped to external line 0. Okay. Furthermore, so you have 15 options here. You have port A pin 15. You're gonna have to put that through external interrupt line 15, the interrupt line 15. So this is pretty straightforward, so that should make sense. Now here's a little thing though. You only really have, if you look at your here, you only really have external interrupt line 0, line 1, line 2, line 3, and line 4. Okay, let me make this bigger. So you only really have these 5 interrupt lines, so which these correspond to pin 0 on all ports, pin 1 on all ports, pin 2, pin 3, pin 4. So what about the rest of your pins? Well, those are multiplexed on these lines. So if you look at this one right here, this is line 9 to 5, or 5 to 9, however you want to read it. Okay, so this is 0 to 4. This one's going to be 5 to 9. So pins 5 through pin 9 are multiplexed on this single line. You know, that's annoying, but that's how it is. And then the remaining pins 10 to 15 are multiplexed on this line right here. Okay, so just be aware of that these all the pins are multiplexed on a single line, but then furthermore you have, you know, this mess going on here. But we'll get to that again once we start coding. So that's how the that's how you know what line you're gonna use. It really just depends what pin you're gonna use. Now let's get into the actual registers of the external interrupt block. Basically, all you're really gonna need is one, two, or one of these, or maybe both of them if that's what you want, and this third register right here. So let's just get through them. The first register is the interrupt master register. Basically, this is where you enable the interrupt for the certain pin. For example, if you're gonna enable the if you're gonna do an interrupt on pin 4, you just put a 1 over here into this register, and you shift the 1 into the 4th bit, and that will enable the interrupt for that specific EXTI line. Okay, so if you want to label line 4, remember, and over here it doesn't really matter what port you're on, because all pin 4s of all the ports are going to go through line 4 of the EXTI block. So you would just put a 1 in here and you would enable line 4. The event mask register I really don't use, so I can't tell you much about that. Now your interrupt, for example, let's say it's a push button that when the user pushes it, you want an LED to go on. Now, when do you want to enable that? When do you want to trigger that interrupt? On the rising edge? In other words, the second that they're pushing it, or on the falling edge, which would be the second that they let go of the button. Again, that depends how you have the button wired. I usually wire my button to ground, and that when the user pushes it, it gets pulled up. But again, so if you wanted the again, that pin 4 to trigger an interrupt when on the rising edge, you would put a 1 to trigger the rising edge for line 4. So everything here is mapped 1 to 1. So you know, this 4th bit is line 4, so it'd be trigger rising edge for line 4 that same line 4 that you did in the interrupt master register right here. And this other register would do the same thing, but this is the falling edge. So if you want your interrupt to happen on the falling edge, that's this is where you would make that happen. And yes, you can do both, but then you'd get 2 interrupts. Okay, the next one is a software interrupt. This is basically when you want to make the interrupt happen without it actually happening in the real world. For example, if I wanted to, in my software, pretend that the user pressed the button, I would just put a 1, I would set this right here, and this would generate that interrupt as if it actually happened. Okay? So this is why this is called the software interrupt event register. So this is where you would by software generate that interrupt. And again, everything's mapped 1 to 1, where bit 4 corresponds to line 4 of your interrupt block. Now, when an interrupt actually happens, what goes on is that a flag is set, and it's set in this register. So when that interrupt on pin 4 happens, what happens is that a 1 is going to be set right here. It happens automatically by hardware. When that 1 is set, your processor jumps to that interrupt handling routine that you're going to write. Okay? Now, here's the thing. So long as this 1 is still set in here, it's going to keep triggering an interrupt. So when your interrupt happens and it jumps to that interrupt handling routine, the very first thing that you need to do is clear the pending interrupt register. You need to clear this so that you tell the processor, hey, I've handled the interrupt, or I'm going to handle the interrupt. So you clear this so that that interrupt is no longer pending. Now, the weird thing about it is that to clear it, you would think you write a 0, but you don't. To clear it, you actually have to write a 1 into that bit. Even though there's already a 1 there being set by the hardware, to clear it, you actually also have to write a 1 into it. And we'll see, we'll do that in the code. Now, another thing we have to look at is the actual how we're going to set. This sets up the interrupts and the events, but we also have to set up the alternate function on that GPIO pin. Okay, so we're going to actually use the alternate function AFIO registers here. Now the way this works is, it's the ones that we're actually going to use for interrupts are these 4 registers right here. The external interrupt control register 1, external interrupt control register 2, 3, and 4. Now, register 1, as you can see, it sets lines EXTI 0, EXTI 1, EXTI 2, and 3. And control register 2 is line 4, 5, 6, 7, all the way up to your EXTI line 15. So this is where you tell those lines what port or what pin you're setting. For example, if we're going to set pin 4, we would go to the EXTI line 4, correct? So we would use EXTI line 4, and we're going to set an interrupt. But it needs to know what port to expect that interrupt from. Because remember, all the ports, pin 4s, are mapped to this interrupt. So I need to tell it which one it is that I'm going to be using. So I'm going to be using, let's say for our example, I'm going to use port B. So I would write a 0001 to tell this register that on line 4 expect an interrupt from pin 4 on port B. So line 4 corresponds to pin 4, and by depending what number I put here, I'm going to tell it which port that interrupt is coming from. So I would write 001 port B. And that's basically how you control what you do with these registers. So if you were to set a interrupt on, let's say, line 14, on pin 14 of port, let's say, F, right? So port F corresponds to this right here, so you would write a 0101 on that. And that's basically how that works. Now, another thing to keep in mind is that in your excuse me, in your RCC register, your clock gating register, you actually have to enable that alternate function. That's the enable register. The alternate function, where the hell is it? Here we go. The alternate function. You have to enable the alternate function. Even though we're setting everything over here, that has its own clock, so you have to enable that. And you would do that by shifting a 1 into bit 0 of the RCC APB2 enable register. And we'll do that all in code. What else am I forgetting? That should be it, hopefully. So let's start getting the code down for this, and we'll run through everything as we're doing it. So the first function we're gonna do is actually to configure the GPIO interrupt. So I'm gonna go ahead and paste this, and you can pause the video and copy it. This is configure GPIO interrupt, and we're gonna pass it first a port, so we know what port our interrupt pin is gonna be on. We're gonna pass it a pin number, and we're gonna select the edge where it's gonna be, if it's gonna be rising edge, falling edge, or you know what I mean. And this is okay, this is a 32-bit integer. This right here is enumeration I made, and that is right here. Type def enumeration, rising edge, falling edge, and rising falling edge. And it's an edge select type def, okay? So it's like we made our own little variable. So then when we call this function, when we're going to pass this edge parameter, we're going to pass it one of these, okay? So here's our function, and now we're going to go to our C file, and we're going to go ahead and we're going to start writing those functions. Again, I'm going to copy it from my file where it's already written, because I'm not going to type this over 20 times. Okay, now this looks like a really long function, and it is, but a lot of it is repetitive. So here is our function. Okay, the first thing we're gonna do is we're gonna go to that APB2 enable register, and we're gonna enable the alternate function. Now this right here is, if you copy this, let me make this big again. If you copy this word for word, this is defined in this document right here. As you can see, it just means it's all it's doing is just setting it to 1. Basically, it's gonna shift a 1 into that, into that what the hell, into that alternate function setting that I showed you in the data sheet. So all it's doing, it's shifting a 1 in here. So you can do it like that, or you could alternately, you could do shift a 1 into the 0th bit. You can write it like that, or you can just write that, whatever floats your boat. So that's enabling the alternate function register. This right here is going to now we start checking for the ports. Okay, so this parameter that we're typing, port. So if they if we're going to configure port A, remember, we have to set how do I explain this? All right, back to the data sheet. This is the way the Stm32 people made this. Let's go here. We're gonna go to our AIFO registers. Now remember these 4 registers, the ones that I told you that that you're gonna set depending on what line. You're gonna tell it what port you want. So the way they set this up is they have the alternate register pointer, and it points to these different registers, but it points to them in an array. And for some reason, if you're gonna access where is it? If you're gonna access external interrupt control register 1 to set these pins right here. So this is a external interrupt control register 1, and remember this one did EXTI line 0, line 1, line 2, line 3, and this is the first one, control register 1. This is where you type in what port it's gonna expect that interrupt on. So they're numbered 1 through 4, but over here they're in an array and they're indexed from 0 to 3. So if you're gonna write to this register right here, you would actually write to EXTI right here to the 0th one, and if you're gonna write to the next one, you would write to 1. So to sum it up, if you're gonna set line 0, line 1, line 2, or line 3 on which it corresponds to the first register, you would actually be doing index 0 right here. So as you can see, line 0, line 1, line 2, and line 3 are on this first register, which is index 0. Now when you're doing line 4, line 5, and line 6 and 7, these are on the index 1 register. So the way they did this is basically they took all these 4 registers, they put them in an array from 0, 1, 2, 3, and it's kind of confusing because in the data sheet it's 1, 2, 3, 4. So that's all that it is. If you can just remember that 0, 1, 2, 3 is really 1, 2, 3, 4. Okay, so the way I have my code here is, let's make it smaller so we can read it. Basically, I'm gonna do an entire if statement, right, with a switch case, and I'm checking for the pin number. So if I'm on port A, correct, and then I'm checking pin number. Okay, so I know I'm in port A, then I'm checking pin number. So if it's pin number 0, I'm gonna go to that first register, right, register 1, which is index 0. Where'd my data sheet go? So I'm gonna go to register 1 right here. I'm on port A. I'm gonna go to I'm checking the pin number. So if it's 0, I'm gonna go to the first of these registers, which is index 0, and I'm gonna shift this right here. Just is 0, 0, 0, 0. That's all that does. And again, this, if you copy it word for word, and then you right click and you go to its definition, it's in that same file, and it has the values written. So for port A is 00, port B is 1, port C is 2. It has all these values right here already written out, so that you're not, that way in your code you're not typing 0001, because that's kind of hard to really read. So again, so that's what we're doing here. So if we're in pin 0 and we know we're in port A, that's why you see all of these say PA, 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 PA. We're in port A. So again, let's go to case 3. So if I'm in pin 3, I'm still in that first register, this first register right here, and I'm going to shift that value, that 000, into the line 3, which is going to be right here. Okay, so you see how it says EXTI3? It's going to shift that right there. Correct. And yeah, so these are all these things are mapped out the way they should be, so you don't have to worry about any of that being wrong. Now from 4, as you can see, now this 4, we have to go to the next register, because this one only goes up to line 3. So we're going to go to the next register, which it's 2 here, but it's 1 over here, and there, and since it's 4, we're doing line 4, EXTI4. This is going to shift the proper value into that line 4. Okay, so I hope that makes sense. So we're going to do all of this for port A. Okay, so we're going to go to line 4. We're going to shift this value for port A into line 4, or line 5, all the way up to 15. And every time we're changing registers once we get to the new register. So over here, line 8, we're gonna have to go to the 3rd register. Line 8 is in in this register, starts in this register, line 8 right there. So it's 3 here, but it's 2 over here. So it's basically 4 zeros, 4 1s, 4 2s, and 4 3s. And then these right here, these are not all the same. You got to look at them carefully. These 2 words are the same, but the line number, EXTI0, will correspond with the case number. EXTI5 would be case 5. And they're all port A. So we do that up to 15 for the entire port A. Now you can literally copy and paste this, and now you're going to do it for port B. The only thing you have to change is this right here, the B over here, and all of these B's right here. Everything else would be exactly the same. Okay? And the same thing for the next register, C, D, whatever. All you're going to change is the letter here and the letters over here. And everything else is the same. So that's why this is a really long function, but it really is just copy and paste. So once you've done that, after you've and this is just setting the alternate. This is basically setting the pin into alternate function mode. Once you've done that, we can check to see what the user passed for edge. Did they pass rising edge? Did they pass falling edge? Or did they pass rising falling edge, which would be both? So if they pass rising edge, we're going to go to this EXTI register, which was over here in our EXTI block. And if they selected rising edge, we're going to go to this EXTI rising edge register, right? And we're going to shift a 1 into whatever pin number they wanted, because remember, the pin number corresponds with the line number. So if they're using pin 4, we would go to line 4. So we would put a 1 over here to put a rising edge trigger on line 4. So that's why right there we go to that register and we put a 1 into the equivalent pin number. Same thing, if they select falling edge, we pass it that into the falling edge register, or if they select rising falling edge, which would be both edges, we just do both of these steps. We would first put a 1 into the rising edge and then a 1 into the falling edge register and the rising edge register. So that handles the configuration part of the pin. The next function we're gonna do, and trust me, now these functions get a lot shorter, is enable the actual GPIO. So now we're gonna enable the interrupt. You can configure it, and then we're gonna enable it, and this is gonna take as a parameter a pin number and an IRQ number. Okay, so go ahead and copy that, and then we're going to write the function. We can write it right under this one, and of course I'm going to copy it from my pre-written thing here. Once I scroll up, okay. Now this one is short and sweet, and it looks just like that. Okay, so this function, all it does is it goes to that interrupt mask register, and which is right over here, the interrupt mask register. And remember, it just, all it does is enables an interrupt on that line. So if we're gonna go to line 4, we'll put a 1 over here, and that's all that one does. Puts a 1 into pin number on the interrupt mask register. And then the second line here, what this does, it enables, because remember I told you have to enable it on the EXTI block, and you also have to enable the line on the NVIC side. And to find that, again, it depends on what line you're using. So if you go to the top of this document here, where you have all your IRQ numbers, depending on what line you're using, that's what you would pass it, and it would just enable it. And this function right here is an internal function that is defined in the core. This right here is a function that's defined in your core files provided to you by the vendor and the people over at ARM. And that's how you would enable it on the NVIC side. So that's that. The last function, well, not really last, but at least the last to these header files, it's going to be to actually clear the interrupt. Because remember, I said that once the interrupt happens, it you have to, the very first thing you should do is clear the interrupt. So we're going to have a function that's going to clear the interrupt, and all we really need to pass it is basically the pin number, because that's all it really needs. Because all this is going to do is it's going to go to this pending register, and wherever line your interrupt is on, all you got to do is write a 1 to that line to clear it. And as you can see, that's all the function is going to do. So that clear interrupt function is that right there, where we're gonna pass it a number and it's gonna clear it. And I compile with no errors, etc. Now, how do we use this? Simple. So this is a code we have, I assume, from last time. It's been months since I've seen this, so here we're using our previously made things here to set pin 13 on port C, to an output, and then we initialize it and it's set. And this one we're setting port A to pin 7 and then we're initializing that. I'm not sure why I have that, but what I will show you is how to actually use the what we just wrote. So we can delete this because we won't really need it for our purposes. So get my keyboard out and we can start typing. So the first thing you're going to do is you're going to call that configure function that we wrote. So it's configure, and there it is, configure interrupt, and we're going to pass it first the the port. So if you remember from our previous code, these ports are already named, so you just start typing. So we're going to use port B. We're going to pass port B. Then the next thing is, what the hell was the next thing? Oh, what pin number, and then edge select pin number. So we're going to use pin number 4 like we've been saying. Edge select would be this enumeration that we made right here. So we can select rising edge, and that should configure it. And then we'll call the enable function enable the GPIO interrupt, and all that is going to take is the number 4, right? Because that's our pin number, and the IRQN number. So since this is pin 4, I know it's on EXTI line 4. So I'm gonna go look at this this vector table here, and I know that EXT line pin number is equal to EXT line 4. So I'm gonna copy that IRQN number, and where am I? And I'm gonna paste that into that. So that's that. Now that handles that. Now remember I told you that when your interrupt goes off, it has it goes to a function, and that function is mapped to a certain address that we saw in the vector table. So for example, EXTI line 4 is mapped to this address. Now the way you handle that is you have to write in a handler function to handle that interrupt, and all it really is you know, start writing the function. You can just copy this right here, the IRQN number, copy that, right? That's how your function is going to be called, except you erase the N from the end. You erase that N, you type in underscore IRQ handler. So IRQ handler, and boom, that's it. That's your function that's going to handle your interrupt on line 4. If you have more interrupts, you know, you're just going to write different functions, each with the corresponding interrupt line. And also remember, the very first thing you should do in your interrupt handler function is call that clear GPIO interrupt, so that it can so it can clear that pending bit, so your CPU, because let's say if you have, you know, a lot of code in this function that's going to happen during your interrupt, well then it's not really going to happen, because your interrupt is constantly going to be calling this function, and it's constantly going to be just running. It's going to flood your CPU, so you have to clear that interrupt pending bit as the first thing you do before you write actual code in here. So again, I don't really have a good camera at the moment to show you this code works, but I've done it a million times and it works. So if I have forgotten something, I will surely probably add it to as a comment somewhere or something, but this is really the basics and enough to get you going on interrupts. on the Stm32. And don't forget that you really have these 4 individual lines, and the rest of your lines are multiplex 9 to 5 and 10 to 15. And you can get smart and figure out how you can find out which pin generated an interrupt. So that's it for now. 45 minutes. I don't know if this came out bad, but that's too long. I'm not gonna redo it. If you have any questions, you can go ahead and comment. I get the notifications on my phone, or email me or something. Alright, that's it.